Okay, now it should be recording. Okay, yeah, so thanks for everyone for coming. That's what I want to show you. The GUI is in German now, but I guess that's okay. I mean, I will explain anyway what you are seeing. So what I started is the CognitionMaster Professional Suite. That's how we called our software. It's really meant as a software suite, which means it's not a single software. It consists of several modules, as you can see. So every blue icon is one module. And the idea behind it is you can also license the modules one by one. So it's not necessary for the end customer to buy the complete package. You can pick the modules that you like and really then only pay for what you like. And the customers appreciate it a lot, I think. Yeah, and yeah, maybe some more general words to the concept and also to the licensing concept. The software is running locally, so it's really installed on the local Windows system, which is, I think, also a big advantage against some other solutions because, well, at least our experience with many customers is that cloud software always is a bit of a hassle because of internet connection, firewall issues, and so on. You know it. So having it locally might be an advantage for some customers. Yeah. Okay. And well, the modules that you see, the first line are our CE certified modules. So they are really clinically usable in breast cancer. So the CE certification is only for breast cancer, not for other tissue types. I mean, you can of course use it in research, but not clinically, only for breast. That's important to know because, for example, KX67 is also used, for example, in NETs and neuroendocrine tumors, which will technically work, by the way, but well, technically and legally are two different things. So yeah, same with HER2, that will also work for gastric cancer, but yeah, legally it can only be used for breast. Then we have some more modules which are research use only. For example, PDL1, also quite interesting, a big hassle for the pathologist to quantify PDL1. I will show it in a little bit more detail. Then we have some reporting and supporting tools. That's not really image analysis tools. That's more for some smaller support. I will show you in a minute. And this line is also interesting because that's our really virtual microscopy tools. So first of all, we of course do have a virtual microscope viewer, which can of course read all the scanner formats, of course including the PreciPoint format. And Scan Connect is a tool to automate workflow processes. I will also show this in a minute. So just to give you an overview. I would like to start with this clinical modules here on top because I mean that's really what we sell most. So I think that is mostly interesting maybe for you because that is easily sold in my eyes to a lot of customers because everyone needs it. It's very simple to use. And you can use it not only with the scanner images, with Holstein images, but also with local saved images or with the live image from the microscope camera. And that's really interesting because, well, I mean, your customer focus might be a bit different because, I mean, your focus as a scanner company is, of course, to sell scanners, and maybe you have more customers that already have a scanner. But our customers are, or our potential customers are really every pathologist, even the small pathologists in private practice, because the software works with what every pathologist has. You only need your microscope and a microscope camera, and well, 90% or 95% of pathologists at least have a microscope camera, and that's all you need. You don't need a slide scanner or any special hardware or something. That's really all you need, and that makes it very nice for also for marketing and for presentation, because yeah, well, everyone can use it really right away. Okay, so yeah, maybe I really also show you the workflow, how to use it with the microscope camera. So I will not, I mean, of course you could go like open file and select your whatever JPEG, TIFF, bitmap, and so on file, but I will not do this now. I will really show you the microscope camera workflow. And to do so, let me first open some images. Yeah, this one, for example. I don't have a microscope and microscope camera at this computer here now. So I will kind of make a simulation with a free image viewer, like Irfan View is a free image viewer, because our concept is we do not communicate with the camera hardware. We did this in the beginning a few years ago. We did this, but we didn't have good experiences with it because, well, you know it. Every pathologist has a different camera. Every camera has different interfaces and tools, and it's really complicated, and is always a big problem. And so we found a better way, which is we kind of grab the image like a screenshot directly from the screen or directly from the Windows system at the end. And yeah, that means we can really grab the image from any microscope camera. We can really say it works with every microscope camera because as long as your image appears on the screen, we can grab it. And by the way, you can also grab this image not only, of course, from the microscope camera. It can also be a virtual slide viewer, for example, or it can be your PreciPoint automated microscope. I don't know the name of this product, but you will know it. Your latest product, this remote microscope. Of course, you can grab it from there. So that's yeah, quite a good tool, I think. Okay, so let's imagine this is the live view of our microscope camera. Our software is running in the background, and when it's running, you will find in the Windows taskbar this black camera icon. That's always there in the taskbar when our software is running. And when I move the mouse over the icon, I will find a shortcut to our modules. So all I have to do is I have to decide in which module to send this image. In this case, that's a KS67 image. So I simply click on KS67, and now there's no feedback, so don't wonder, but it's already analyzing in the background. I can stay in the case and move the microscope maybe to another region, like this one. I will click again on KI67. The software will collect the images to this case in the background. Maybe I find at least a third image, and that's not so nice. Yeah, that's again a nice example. So I will send this again to KI67. Now I clicked 3 times. Now I will move back to the software. Now you can just see how the last image is calculated. It takes about 2-3 seconds per image to analyze. Yeah, now it's done. Now we have our 3 regions of interest here at the right side of the software. So I can click through the regions. That was the second, that was the first one. And above this blue line, you will find what we call the global score. So that means the overall score of all 3 images. So the average score is 51%, and the standard deviation is 18.9. The standard deviation is very high now because it's of course sample images. It's not the same case really. It's just test images. But well, you get the idea. And I think that's really the workflow that the pathologists mostly use our software, including really making several snapshots or several regions of interest per case, sometimes even more, 5, 6. because it's very easy. You do it while you anyway do what you're doing, which is looking under the light microscope. And always when there's a nice region to analyze, it's just one click away, and you have your result. And now that we have the results here, I can of course still do some editing, or I can select what I want to use for the report and what I don't want to use. To give an example, if I might say this image is for some reason not really nice, I can simply click on remove here at the top right, and well, this region of interest will be removed from the case. The average scoring and standard deviation changes immediately. I can also select single regions from one image. For example, I don't know, if I might find this region in the bottom left is for what reason ever not nice, not interesting, I can select it. There's this selection tool at the top, simply by dragging a line around it. And I could then, for example, say, okay, I want to delete this from my calculation, and then it's not regarded anymore. Yeah, anyway, to maybe to explain what the colors mean. You always see it when you move the mouse over the detected objects. Red means positive tumor cell, green means negative, and there's also black, which means excluded. And excluded are objects that are not cells at all, like stroma or artifacts or things like that, or that are lymphocytes. Like this, for example, here might more be a lymphocyte than a tumor cell. So the software will detect this and not calculate it to the case. What is also really often used by users is this colorful button here at the top that lets you switch between the original image and the detected objects, which really makes sense. I always recommend customers to really do this, to really make a quick check if the software was okay, if the detection was okay, because, well, I always tell the users what the software does is really the absolute last point in a long processing chain, and everything that happens before this software analysis will of course influence the result. Like, for example, if the image in the microscope camera was not in focus, just to give an example, or if the staining in the lab didn't work for some reason, that will, of course, I mean, the software can't improve it. If there's a bad image, the software will bring a bad result. And so it makes sense, and it is necessary to make a quick check if the image was okay and the software really detected it properly. Like here, those two images are really quite nice. Yeah. Sometimes, I mean, I could point out some single cells. I also always tell the customers really honestly, of course, a 100% correct calculation of something is never possible. I mean, that's totally clear, and we have to be honest at this point. It's always an optimization problem, and you will always find single cells that might not be detected or that are incorrectly detected. That's for sure. There is no 100% correct detection. Like, for example, if I have a closer look to this image, this here might be another positive cell. There might be a positive cell. Here at the bottom left, I might find another negative cell. So yeah, just to show it, of course, it's not 100%. But our experience, well, not only our experience, also the clinical validation found that what might not fit perfectly is the total amount. Like, for example, this 496 tumor cells, that might well be 520 or 490. But the ratio, the positivity rate, that's really quite correct, because in most times when the software doesn't find all cells, it will skip the cells in the same ratio. So it will skip in the same ratio negative and positive cells, like in this example. So the positivity rate is really quite nice, which is also the result of the clinical validation. But still, if customers do want to have a 100% correct result, you can still edit this result. For example, I could click into the image and I could say, I want to add a positive object manually. Then I click on this and I can add things manually. Maybe there's another negative, there's another positive. However, you get the idea. You can also edit the classification of already existing objects. Let me have a look if I find an example where it makes sense. That's quite okay for me. But well, however, yeah, maybe this one, maybe I would say that should be a positive cell. The software said it's excluded, I guess because the morphology is somehow strange. Then I can click into this existing cell and simply say I want to label it positive. But well, it will not change much in the result, because 500 tumor cells, single cells don't play this big role. Yeah, so that's nearly everything it is for one module. We found it important to make it simple, to not have too much buttons and not have too much options. The idea is really do one click and wait 2 seconds or 1 second, and you have the result. And that's what you saw. And I think that's what makes the software so successful, because it's really easy and really made for the pathologists and not for the IT personnel. Yeah. Okay, now that we have our nice result, we might, of course, want to save it. So let me do this. Oh, I opened a project file, but yeah, that shouldn't bother you. I will show you some options to save it. The most simple option is create a report somewhere. I will put it on the desktop so I can find it. And a report then looks like this. So we saved the complete result into an image file. So what you see is an image file. There you can see it. It's a JPEG file, which includes the image results and the text results. So the text results are kind of burned into the image. We did this because an image file is most compatible. You can drag and drop it into, I don't know, Word or your information system or whatever, and it will always work. And the image shows you, well, this is the medical product ID. Then you have your result, the standard deviation, and then every image that was part of this result. In this case, it's 2 images, and at the bottom, the statistics, date, time, software version, and so on. So that's one way to save the result. Another important way is we developed interfaces to several pathology information systems, like, for example, in Germany, the market leader Nexus, or in Switzerland, Basisdata, or, well, I don't know, Cofox is one of the newer modern systems. Well, there's a lot of interfaces to several information systems, and those interfaces allow to export the result directly into the findings report of this pathology information systems. So that's really nice then. For example, in the case of Nexus, Nexus will take over the result images into their, they call it like, I don't know, file collection or something like that. And the structured information, so the information Ki67 marker 33.8% positivity, this structured information will also be taken over by Nexus, and they include it directly into the textual findings report. So the pathologist doesn't even have to type it or say it into an audio file or something. It's automatically there. So that's really nice solution. Yeah. So that's basically what you will do with one of these modules. And the same way really works with the other modules. So the workflow is basically always the same. You can grab your image from the microscope camera or any other desktop application and simply decide for another module. So to show you another one, HER2 is also very nice and often chosen by customers. Let me show you an example image. I like this example because it's not an easy image. It shows some inclusions of non-tumor, as you can see. So it's really not an easy image. But well, I wouldn't show it if it wouldn't work. So I think the software detected quite nicely the regions which are not tumor. So they are black, which means excluded, with some small errors like these 3 cells. The software said negative. I don't think this is true. I would say they are also non-tumor cells. So I could again change it, but yeah, again, when we found in this case what it is 600 tumor cells, some 3 cells will not make a big difference. Yeah, so HER2, same concept. We can grab the image. We don't have to do any settings or so. The result is directly there. In the case of HER2, because it's the breast cancer scoring system, we do not only have positive and negative, we have the 3 positivity ratios like demanded from the breast cancer analysis scheme. So we have 3+, which is in this case red. We have 2+, which is pink. Yellow is 1+. Green is again negative, and black is again excluded. So in this case, it's just over the cutoff for 3+, because the cutoff in this case is 10%. If it's more than 10% 3+ cells, then the overall score in HER2 for breast cancer is 3+. So it's just skipped to 3+. Yeah, and all the rest is again the same. Saving the report, editing the result if necessary. It's always the same idea. Then the third clinical module is ER/PR, estrogen and progesterone. We made this one module, not 2, because it's really from the workflow, from the scoring, and from the analysis. It's really the same. So it's really just one module. What might be a bit different to KS67, we can also calculate the Remele or Allred score automatically. If people use it, some use it, some don't. However, the software can calculate it. Yeah, and well, that's basically really these imaging modules. There are some more, just to have a very short view into this. There's PDL1. Customers always are very curious to see PDL1, but well, it might be a little bit disappointing that we do not calculate the what is called the combined score and the what is called the TPS score and CPS score and the immune cell score. That was what I was missing. It would be more interesting to calculate the immune cell score, but we do not yet do this. We started with the TPS score, which works quite nice. I will show you. Or whatever. I will pick just the first image. So that will analyze the TPS score, which is really quite nice. But well, I know for pathologists it would be more interesting to also differentiate between immune cells and tumor cells and be able to calculate the immune cell score. But well, that will be the next step. It's the first version of the software. We will improve it. Then we have CD3 and immunoquantifier. They are very similar. Actually, immunoquantifier is kind of a newer version of CD3 quantifier. The difference is in CD3 we calculate or we count the absolute number of positive tumor cells in CD3, 4, 8, 15, 20, 103. That's interesting for some cases, but many pathologists then said, well, but they want to analyze the sprue, and for sprue, you need also the amount of negative tumor cells and want to get the ratio. And so we made another module which we called immunoquantifier, which works for the same tumor markers, but will also detect negative tumor cells, so that you can calculate the sprue ratio. Can I show you a little example? Or okay, that's not the nicest image. It's quite not in focus, but however, just to give a very, very quick idea. It takes some time, I guess, because it will find there's a lot of clusters, because it's really not in focus, and the positive cells are very close to each other. So yeah, it found a lot of clusters. Yeah, but that gives me the chance to tell you the software does see that these are clusters. If I move the mouse over a single object, you will see it tells me number of cells 1. And in the case of a cluster, it does know it is a cluster and makes a cluster analysis to find out how many cells are this cluster. And there you see it counted this cluster as 11 cells. So even if it's a cluster, the software still counts it quite correctly. Yeah, I think I will skip this reporting tools. They are not so much interesting. Just to tell you, Report Hub is something that can be used mainly for research projects. It's really a reporting tool, so you can create a project file and then save all the results of our quantifier tools into your Report Hub project, and then, well, collect all your results and at the end export it to Excel. So that might be interesting for research projects where you want to analyze hundreds or thousands of cases and then have your Excel table. You can do this with this reporting tool. But for you and your customers, that might be another point of interest, our virtual microscopy tools. Well, first of all, we have a microscope viewer that will not be so much different to your viewer or to any other virtual microscope viewer. Well, they are like they are. Still, I will give you a little insight. There is a case search behind it. So I have an example case called 111. If I search for 111, it will give me all slides to this case. Then I can say open case, and it will open the first slide in this case. And if I move the mouse to the right side, it shows me an overview of all slides to this case. And by the way, this case search, which I did in the beginning, this can also be triggered from other systems. Again, we have this interface to different information systems like Nexus and so on. And yeah, for example, for Nexus, we realized also the interface in the other direction. So if you open your case 111 in Nexus, we will get the information from Nexus via this interface, which case is open. Then our software really fully automatically searches in the background in the defined storage location for whole slide images with this case name or this number, and opens it. So It's really a zero-click solution. It simply opens fully automatic. If you don't want to see these images, you should look at them, but they simply open fully automatic. Yeah, and well, these images are then again also linked to the quantifier modules. So if I maybe open the KI67 slide, and well, I have now several options again to make image analysis on my whole slide images. One option is I can select regions manually, like maybe this region. And then there's another menu here on top, which gives you some tools for this actual image, like saving snapshots, doing annotations, and so on. And another option is make a digital analysis of this region. So if I click there again, it will analyze this region in the background. So it's now already analyzing in Ki67 quantifier. I can, just like with the light microscope, select another region, again, send this in the analysis, and so on. When an analysis is ready, it will give me this yellow envelope. So if I click there, it leads me again to KS67 quantifier, and there you go. This is the result of this region which we just selected. So that's one option. That's the analysis of single regions. But I will delete this and show you another option, because what I now did manually, this selection of interesting regions, of hotspot regions, can of course also be automated. And that is done in this tool. We called it Scan Connect. The idea of Scan Connect is kind of a connector between scanner and viewer. That's the idea. That's also this name, Scan Connect. The concept is it works like what we call watchdog. So the software monitors the output folder of the slide scanner, like for example the PreciPoint slide scanner, of course, or any other slide scanner. So it monitors the output folder, and as soon as there's a new image, the software will wake up and run through a processing chain which you can define beforehand. So it's really fully automatic. And we did this because the analysis on whole slide images really takes time. That takes about, well, 2 minutes for biopsy, and could be 3-4 minutes for an ectomy. And in so far, that's not, you don't want to wait 2 minutes. And so we made this really fully automatic. It runs 24/7, monitors the output folder, and analyzes automatically. And in this Scan Connect module, you can define your processing chain. So there's several things you could do. To give you an example, that might not really make sense. It's just to show you everything that we can do. The software can, for example, communicate with information systems. For example, to ask which staining does this barcode, which we read from the slide, which staining does it have? You can convert the image. You can copy. You can sort by names or by barcodes into projects or whatever. So there's a lot of things you can do. And you can also do this automated hotspot detection. That's what this here means. And you can define some parameters. In this case, for example, I said I want to detect 5 hotspot regions of the size 600 times 600 pixels in everything that is somehow defined as Ki67 slide. And well, that takes a few minutes, so I will not start it now, but I can of course show you a result, not here, in the microscope module. Somewhere I should have example images. Yeah, they can already see it. We do support several formats, but well, let me open this one. I don't know if it's a good example, but we will see. Yeah, looks quite okay. Yeah, there you go. So these regions here are not done manually. They are detected by this hotspot tool. And I can now open the result table. And that gives us, first of all, the overview of this 5 region in this case. So that's exactly this 5 regions. And another click leads us again to KI67 quantifier, to the exact same module, which we already saw a few times. And yeah, that's the imaging result of these regions. So it's 5 single results. And again, you have the overall result, which is 33%, which with a quite low standard deviation, 5%. So that looks quite plausible to me. With a click on one of the regions, it leads us back again to the whole slide image and to the exact region where I have been in KS67 quantifier. So the 2 modules are linked to each other. Yeah, and well, again, same concept as in the quantifiers. This is always just one concept, one idea of the software. Of course, the pathologist has all the options to decide what he wants to do with it. I can delete single hotspot regions if I think they are not fine for whatever reason. I can add further regions. If I think I want to add this, then I simply press on plus and so on. So the software always makes one suggestion, but the pathologist is, of course, the one who makes the decision and who can still make changes if necessary. Okay, and well, the rest of the viewer is, as you can see, like you know it from PreciPoint Viewer and others, zooming, panning, having overview images, well, and so on. That's nothing really special, I think. Yeah, so I think that was a quick run through the most important modules. Yeah, yeah. Also, in order to not make this video too long, let me stop at this point. And first of all, maybe you have some questions. Yeah. So, what do you think? Do you have some questions? Everyone is muted, which I just see. So if you have questions, please unmute.
For me, no questions. Thanks, Kai. It's really interesting. But at the first time, I have no questions at the moment.
Okay.
When I have questions, I will contact you if it's okay for you.
Absolutely, of course. I mean, anyway, every one of you can of course always contact me. You will have my contact data, so yeah, of course, always contact me in case of questions.
Great.
Okay.
From my side, I have a couple of questions.
Excellent.
I could sound silly, but yeah.
No.
First of all, does this system has to be installed in the Anapath computer or is on internet?
No, it's really not. It's a very good question because it's important for customers to know, and also the customers always ask this question. So it's really a good question. No, it's not running on the internet. It's not a cloud software. This is really installed locally on your Windows machine. So if I close it, there's the icon in the Windows system. So it's really running locally on Windows. And it does not need internet, and the calculation is also not done in the cloud, but really locally. Yeah.
Okay, nice. And do you have any other certified items for the future? Because I will be really straight. These 3 K67, HER2, and the other are really common, and maybe there are hospitals that are specialized in others, and that could be like for your side and our side more interesting to have a huge pack of AI, but this
Yeah,
is just
absolutely.
an internal question, you know.
Yeah, no. It's also an interesting question, and also something that customers like to ask. And you're totally right. There's a reason why we made the CE certification for this 3 modules, because they are the most common modules, and we simply sell it the most. Well, because as you know, CE certification costs a lot of money and a lot of time. So we really have to decide, is it worth it? Do we get the money back if we make a CE certification of something like CD3 quantifier, for example? So that's really the reason. We made this 3 certifications, because we will get the money back. We will sell it quite often. But yeah, that's a hard calculation for some of the other modules. So that's the major reason. But well, still we are, of course, developing more modules. In the moment, we are working on a HER2-ish quantifier. Next thing we want to do is we want to improve the detection of the tumor region in whole slide images. So we are working on a lot of things. And we will also, or we are willing to do CE certification for further modules, like for example for this tumor detection. We are planning to do an IVDR certification, but that takes some time and some money. So I will not promise when and for which module we will have this.
Yes, thank you. And another question: in the moment when the customer purchase this system, does the person have the access to all of the C module, or just one?
Well, both is possible. You can simply decide. The module concept, we also made this because of this purchasing options, because the modules can be licensed one by one, or the complete package, or a combination of 3 or 5 modules. So it's whatever the customer wants. We have a price list which basically has the 2 dimensions: amount of client PCs and amount of modules. And those 2 numbers decide on the license price. So it's as easy as that. So yeah, you can pick the modules you like and only have to license those modules. And by the way, we also made the price list. We have client licenses, so there's no volume licenses. So our license always means the license is valid for 1 computer, no matter how many usages on this computer, and also no matter how many people use the same computer. It's really a computer license. Yeah.
Yes, that will be my next questions.
Yeah, okay.
So thank you. And yeah, so you're flexible around the bundle and stuff to sell it.
Absolutely, because we also found that customers really appreciate it a lot, because there are some customers who say, well, I only need KR67, which is totally fine. And then we have other customers who say, yeah, I want to have these 3 modules. Then there are others who say, I have a slide scanner, I also want to have these modules. So that's really important to have this flexibility to customers.
Yeah, I totally agree with you.
Yeah.
And I think that's all from my side. Thank you.
Yeah, thanks for your question. That was excellent questions, and gave me the opportunity to tell you some important things. So thanks a lot for the questions.
Thank you, Kai. Do you have other questions, guys?
I don't have any questions. I already know the product. Thanks again for the further or deeper explanation. Yeah, you could say that. we had a meeting before, Kai and me, with one client. So yeah, twice today.
Yeah, that's right.
Oh, nice. So you are really used to this program.
Yeah,
I find it really interesting, really intuitive. So my
Yeah.
congrats. And yeah, I'm just like a little bit concerned about Ki-67 just because yesterday I spoke with a customer specialized in breast cancer, and he was like, yeah, there are several ways to analyze the Ki-67, and there's no one like unified way to do it. And so he was like, yeah.
That's right. So that's also one reason why we do not show, as a result, we do not show, I don't know, a diagnosis scheme or something. We only show percentages because cutoff rates are changing. So what the user makes with the result, what this 33% means for him, we leave it to the user. It's not nothing that the software decides. And that makes it, I think, also flexible to different scoring systems and so on.
Yes. I agree. In fact, you can choose the area you want to analyze because, for example, he told me that they do the analysis in hotspot, but also on peripheral region.
Yeah, exactly. And so you simply choose the regions you want to analyze. I know often people say, well, I do not only want to have the hotspot regions, but also the lower proliferating regions. So, and well, then you can pick them. So that's not an issue.
Exactly. Yeah. Thank you.
Okay. Yeah. Thank you again to you. I will now stop the recording.